Okay, so this is a recap. We are starting to just revise Form 1 Lesson 8, common factor, common multiples, and prime factor. Okay, let's look into this module. First question, we are asked to place numbers from 1 to 35 correctly onto the Venn diagram. So we started with number 1. Now, of course, number 1 is a factor for all the numbers. So you put it in the common area. Common area is the one that overlaps both circles. All the factors of 24 will come inside this circle. All the factors of 35 will be written inside this circle. And if they are common, that means they are for both the numbers, then they will occupy this space in the middle. So we started with 1, of course, 2, 3, 4, 5, 6 went here, 7 went to 35, 8 went to 24. Now the next number we were at, or we are doing now, is at 9. Where would 9 go? Cannot be divided by 24. Cannot also go into 35. So you put it outside the circle, but inside the rectangle. Do you see that? 9 is a factor, but it's not a factor for 24 or 35. It's a factor for other numbers, but it's still inside the Venn diagram. Understood? So 10, where will 10 go?
Outside.
Also outside. 11?
Outside.
Outside. 12?
In
24.
In 24, only for 24 because it won't overlap. It's not for 35. How about 13?
None of them.
Outside. Okay, outside. 14?
None.
None. 15?
None.
None.
16?
None.
17?
None.
18?
None.
I hope you guys are doing this on your side. As I'm doing here, you also do it on your side. 19?
None.
None.
20?
No.
None.
21?
No.
None.
22?
No.
None.
23? I got no space already now. 23?
None.
Okay, 24. Where will 24
24.
go?
In 24.
24 will go here for 24 itself, okay? And then 25,
No.
outside.
None.
26, outside.
None.
27, 28, 29, 30, I'm sorry, no space, 31, 32, 33, 34, and finally 35 will go in for 35 itself. Can you see this now? Because there's practically no numbers that would actually overlap. Now, is there a number that would be in the factor for 24 and 35? Look at it. Ada ke?
No.
None. Because 35 is made up of 3. 35 made up of 5, 7, yes, and 35 and 1. Okay, these are the factors for 35. The factors of 24, yes, you got a lot here. But none of them are the factors for 35. So the common factor here is only 1. All right? So this is just an introduction thingy. Okay, this was our lesson 08. Clear? Let's move on to question 2. So what are the common factors? The common factors is only 1.
1.
Now, what about this number 1 to 18 for the two numbers here, 12 and 18? Okay, so you try now before I do it. Start doing, okay? I'll give you like go ahead by about 10 seconds. Okay, start now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'll start and you check. So 1 will go here because it's common for both. 2, is it divisible by 12 and 18?
Yeah.
Yes, the 2 will also be common. How about 3?
Yeah.
3 is also common for both. How about 4?
Yes.
Only 6. 6 is common.
Only 12.
Only for 12. Okay, we are doing 12. How about 5?
No, nothing.
Not for anything.
None outside. How about 6?
For 12.
Common.
Hey, 12 and 18. Can you see? 6 can be divided by 18 also. So it's a common. How about 7?
No.
Outside.
Nothing.
How about 8?
No.
Outside.
Nothing.
How about 9?
9.
18.
Only for 18. How about 10?
Nothing.
Nope.
Nothing. How about 11? Nothing.
No.
How about 12?
12 itself.
You
Yeah.
believe for 12. How about 13?
Nothing.
Nothing.
No.
14?
Nothing.
Nothing.
No.
15?
Nothing. No.
16?
Nothing.
17?
Nothing.
And 18
18
goes for
for
18.
itself.
You see this? Now, what are the common factors? Your answer would be 1,
1,
2,
2, 3, 6.
3, and 6. Next question, what is the highest common factor
6.
among these?
6.
Yeah, 6. You see that? So this diagram is called Venn diagram. Oh, we didn't answer the earlier one. What are the common factors? It's 1. Can't for the first question, miss that out. Okay. So far, so good? Clear?
Yes, teacher.
All right, good. Let's move on to our next question. Okay, find the common factors of the following numbers. Use the Venn diagram to help you organize your work. Can you guys do this now without my help?
Teacher, do we have to write the numbers that are not the factors of anything?
Outside here, but inside the rectangle. That means you're asking whether I should write, say, 5. Where would I write 5? You write it outside here.
Okay, teacher.
Is that what you're asking?
Yes, teacher.
Yes. So guys, I am going to skip this part because I believe that with those 2 examples, you can actually now do this. You start with 1. 1 is going to be a common factor. Okay. Then you go to 2. You go 1 by 1 until you reach the highest number here, 8.
8.
Over here, you'll have to do it until 16. You see, over here, you'll have to do it until 32. So you can imagine many numbers might go in at the sides. Okay. So in that way, using Venn diagram, you can find the highest common factor. You can find common factors as well. You can find also all the factors. Remember, these were the things that we learned. When you learn about, first you started learning, you learned about factors. Then you learned about common factors. So this is the common factor part. Then you learned about the highest common factor and find the biggest number here. Do you see that? Okay. All right. Good. Now clear. Let's move on. This one has got like 6 questions. So I believe you guys can do this. Let's look at page 3. What do we have here? All this is using your knowledge of factors. Okay. We want to try to help you to actually understand what a composite number is. For example, 3 times what gives you 24?
8.
8, good. All right. So 8 and 3 are the factors for 24. Do you understand? Okay. Now 8 times what gives you 32?
4.
4. So 8 and 4 are the factors for 32. Now over here, 3 and 9, what is the product over here?
27.
27. And 9 and 4, what is the product over here?
36.
36. So what are we doing here? We are using our knowledge of common factors to complete the following multiplication grids. Pretty easy an exercise, not too difficult, but can be a little challenging. Okay, let's try a little one of those end questions and see. Okay, all of you, let's go and try D. Okay, let's do question D. You have got 4 numbers here. You got to think now, what times what gives you 63? That other number times something gives you 105. And then over here, maybe I'll just have to label this A, unknown kan? You have learned unknown, isn't it? A, B, C, and D. So this is all now unknowns. So A times B, what 2 numbers possibly you can think of that will multiply to give you 6 and 63? Tell me now. Can we have some options?
31 times 3.
9.
31? No. 31 times 3 or 21 times 3?
Teacher, you said 21.
Oh, it's 21. It's 21. Sorry.
It's 21 times 3. Some more? Anything else?
9 times 7.
Very good. 9 times 7. Anything else? Don't forget lah, 1 times 63. Okay, I said that. Who asked you not to say? Remember, 1 times 63, you're going to get, still it's a factor, kan? So this is good, 21 times 3, 9 times 7. Do you think can divide by 4? Cannot. 5 cannot. 6, 7, 8, 9. I think that's about it, right? Okay,
Yes.
good. Now, let's go with this pair. What times what can give you 48? Work out the factors. Can you give me some?
Teacher, 2 times 24.
6
Okay,
times
2 times
8.
24.
1 times 48.
Wait. 6 times
8.
8.
8. Some more?
12 times
4 times 12.
4.
12 times 12, no?
12 times
4 times 12. Not
Oh,
12 times.
sorry, 4 times 12. Anything else? Anything else? Can you think of any other pairs that will make up 48?
3 and 16.
Very good. Is that who's that who said that?
Bishop.
Rishabh, very good. 3 and 16. That's another pair. So 3 times 16. Anything else? Divide by
think that's
2, 3, 4, 5 cannot, 6, 7 cannot, 8 got already, 9 cannot, 10, 11, 12. I think that's about it. So these are all the possible numbers to be put in for C. You understand? And these are all the possible numbers to go in for either A or B. All right. And this could be either A or C. Remember that, huh? Now let's work out this range now for this, for 105. Or maybe 80 will be easier. Kan? Tell me, what can make up 80? I will tell. First one, 1 times 80.
2 times
2 times
40.
40.
2 times 40. Good.
20
Some
times
more?
8 times 10.
Huh?
4 times 20.
8 times 10.
8
4
times
20.
10.
4 times 20.
4 times 20.
20
Okay.
times 4.
40.
5 times
40.
16.
Come again. 5 times.
16.
Very good. 5 times 16. Okay. Now, what else do we have? Any others?
That's it.
That's it.
20 times 40.
20 times 40. No, 20 times 4. 20 times 4 is the same as 4 times 20, kan?
Yeah.
Anything else? Is there anything
That's
else?
it.
I don't think so.
Probably that's about it. Okay. Now, the last one. This one, 105. Use your calculator, guys. Okay. At this point, you don't have to do everything mentally. So use your calculator. You all have calculator. Try. Can 105 divide by 2? Cannot. So it
No.
must be
No.
3 times something. So take 105 divided by 3. What do you get?
35.
Huh?
35.
35. Okay, 35. Thank you. Okay, can 105 divide by 4? I don't think so.
No.
No. Can 105 divide by 5? Well, so 5 times what?
5 times 21.
31.
21.
Come again?
21. 5 times
21. Okay, 21. Okay, and then can 105 divide by 6?
No.
No.
I don't think so.
Divide by 7?
Yes.
Times 7.
How many?
7 times
15.
15.
15.
15. Okay, good. Can you divide by 8?
No.
9. Can you divide by 9?
No.
No.
Can you divide by 10? Cannot. 11?
No. No.
13.
13. No.
You know what I'm doing? I'm actually checking out all the primes. Okay, now go move to 17.
No.
Okay, 15?
15, 7 times
Yeah.
15.
15 is
15
already here.
will
15
go.
is already here.
15
Okay.
will go.
So 17, how about 19?
No.
Okay,
No.
we'll leave it here. At this point, maybe if there is also, we haven't found it yet. Now, can you now figure out what combination could A, B, C, D be? What could it be now? Think. A, your options are all here. You know? It's kind of like our. I'm going to pause it for a while. Pause the recording. Right. So as mentioned above earlier, we can use these factors 3. Can you see it's common? So you can put it into A, the value for A. So 3 and 21. So B will be 21 and you'll get 63. Okay, out on this side. So 3 will pair up with 16. So 16, you can write it here. So it will work out to 48. And then 21 and 5 will pair up here. See, 5 times 21. So D will be 5. You get 105. And finally, 5 and 16 pairs up here to get 80. Okay, all these are factors. These would be definitely easier to do. This a little challenging. So we have done the challenging one. Now we move on. Okay, move on. We come now to the topic or to the exercise of finding common multiples. What method? Can somebody tell me what method are we using here to find this?
Kaedah bahagi.
This is bahagi ka? Belum. This is not
Oh,
bahagi
wait,
method.
LCM.
This is the listing method. You know what is list? Create a list. Can you see? I'm listing out. Can you see that? So this is called the listing method. List the multiples of each number. Remember, now we are looking at multiples, not factors. You have got to change your mindset. 12, okay? If I ask you for factors, you can tell me 1, 2, 3, 4, 5, whatever, not 5, sorry, until you reach 12. That's factors. When I talk about multiples, you start at 12. You understand? It's the times table of 12. So don't confuse yourself between factors and multiples, okay? Clear? Clear. So list the multiples of each number and use your list to find the lowest common multiple. Example 7 and 3. 7, 14, 21, 28, blah, blah, blah. Multiples of 3, 3, 6, 9, 12, 15, 18, blah, blah, blah. At this point, 21 and 21 is where they meet each other. That is the lowest common multiple of 3 and 7. Now, is there any logic in finding the highest common multiple? Never, because multiples will keep on going on. Numbers are infinity. So there is no sense in finding highest common multiple. We only want to find lowest common multiple. Understood? Good. Now, on your side, what do you do now for 3? You list all the multiples of 3, starting with 3 itself. Go on, 6, 9, go on, 12,
15,
and
18.
15. Okay, enough. Now, go to 4. Now, why do I say enough? Do you know when I say enough? Because in my mind, I am also trying to see which number is in times table 4. And I know immediately I will meet at 12. You see that? 4, 8, and 12. That's it. So the lowest common multiple of 3 and 4 is 12. And to find this, we use a method called the listing method. Earlier, remember this one? What do you call this? You have this
Venn diagram.
Venn diagram. This is the Venn diagram. Okay. And this is listing. All right. There are so many ways. That's what maths teaches you, right? Many strategies for to find a common answer. I believe you can do this now. Multiples of 3, 3, 6, and 9. And definitely 9 is already there. Yes or not? So the lowest common multiple is going to be 9. Pretty easy. So in that way, guys, I hope you can actually do this very simple exercise, finding common multiples using the listing method. Got it? Clear, 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 clear. Look here. We have got about 10 questions here. So multiples of 25. Okay. I want you to work out this question and put in the chat now. What is your lowest common multiple for this number 10? Come on, try. Use this method, listing method, okay? And try to tell me what is your lowest common multiple. Hello, guys. I must pause the recording because if not, the recording will become boring. Now, okay. All right, clear. You guys cannot do anything. I didn't record what I said, okay? So now we go to factor trees, all right? I think, is this the last page? No, not yet. But yeah, almost nearing the end of the module. Factor tree is a very important idea, method, strategy again. Amazing fact. Let's see. Guys, do you know where this one is pretty interesting. Do you know where's the tallest tree in the world? Where they are?
Giant sequoia.
Amazon.
California.
Yes, not Amazon, darling. It's not in Amazon.
Giant
It's in the
sequoia.
Sequoia National Park in California. Hey guys, you know how tall are those trees?
These are
Look.
40, 50
100,
meters tall. No, it's not
very,
150.
yeah,
Yeah, correct. 150, correct.
yeah, it's more than 100 meters, most of them, you know, and I think it's called the redwood. Yeah, it's called the redwood forest.
The
You know,
general shaman tree also, that's what its name.
oh, that one I haven't heard,
Yeah,
but
yeah.
this one, yes. Okay, but all right. So if you happen to go to the United States one day, go to the Sequoia National Park, visit. Okay, you will find.
It is in
Yeah.
California.
Yes, it's in California. It's in the
Okay,
US.
okay, my
Later,
aunt
maybe I'll
lives
send you
there.
pictures. All right. Okay.
Teacher, take
So,
us there.
one flight ticket 4,000, you know, to and fro. Okay, you pay the flight ticket lah. I can take you and go. And then accommodations are more, don't forget. Okay, now guys, let's get back to our factor tree. What is our factor tree? Remember factors? We make a tree out of it. Okay, so it's just joking. So factor trees are a great way of finding the factors of a number. So earlier, remember we used Venn diagram. Now factor tree will be like this, breaking it up. And you guys have got this practice even in standard 6. I've done this with you, those who were with me lah, kan? Break it up. 6 times 7, yes, I get 42. But I'm going to break up my 6 further into 2 and 2 times 3. End of the day, what am I getting? I'm getting all primes at the bottom. Can you see that? And another way, if I break it up also, I'll still end up with the same number of primes. Same primes, in fact. If I broke up 42 into 6 times 7, I will get 2, 3, and 7. If I broke up 42 into 2 times 21, I still must break up 21 into 3 times 7. End of the day, all numbers in this world, all composite numbers are made up of primes. That's what your factor tree is all about. It's breaking them down. Okay? So let's see. Why do they actually call it factor tree? Where is this idea? Tree is supposed to be like that, isn't it? Kan?
Yeah.
What do you think? Why is this going downwards?
The root.
Correct, the roots. Very good, clever. Soalan kebat. Nah lah, just joking. All right, guys, let's go. Me sponsor you pula. Very clever. 100,000. How many of y'all here? 6, 7. Okay lah, if I win the lottery lah, okay? If I become a millionaire, then why not? We can all go.
Teacher, take loan from Loan Shark.
Hey, loan shark all don't come and talk to me, man. I'm a good maths teacher, okay? Not going to go to loan sharks all. All right, guys, let's move on. And oh my God, all this is being recorded. Kadavali. Okay, please lah. Okay, here we can see some of the factors of 42 are 2, 3, 6, 7, and 21. Is it so? Can you find any more by starting another factor tree for 42? I think tak payah lah. Okay, we can skip this part. All right, skip this. Let's move on to more important questions. Use factor trees, okay, to find the factors of the following numbers. So I do one example, okay? You should be able to do it easily. 21 would be, come on, tell me, what would be the factors?
3 and
7. And this is already prime. I cannot break it up anymore. Can you see that? So that's it. The factor tree is very easy, very simple, okay? What about, okay, again, more examples here. 48 broken down like this. And over here on this, I have given more practice. So fill in the gaps with each prime factor tree. So over here, 20, factor is 4 and 5. 4 times 5 will give you 20. 5 is already prime. 4 can be broken up into 2 times 2. So this is now your prime factor tree. Why prime? Because end of the day, it's all prime numbers at the bottom. Okay. Over here would be 3. 24 over here. 4 means what number would come in here? 6. Okay. All right. 6. Wait. 6. Okay, good. And then over here, 2 and 3. So you see, so what are the prime factors for 24? 2, 2, 2, and 3. If you multiply all of this, you'll get 24. You see that? So in the same way, you can complete D, E, and F. I believe this is not that difficult now that you have learned so many times about factors. Move on and also complete the factor trees on page, what is this? What page is this, guys? Wow, what page is this? I forgot. How many pages now? 1, 2, 3, 4, 5, 6, 7. That's it. 7 pages on your module 1 or module 8. And it's just this. Doable? Boleh buat?
Boleh.
Boleh. Okay?
Yeah, can.
Okay, can do this. This shouldn't be that difficult. So after this, we'll take a quick break, maybe like 1 or 2 minutes. Then we'll move on to the next module. Okay, so I'm going to stop sharing and also pause the recording for